Hello everyone, welcome to this new playlist in our channel, End-to-End AI Projects for Interview Preparation. This playlist is about creating end-to-end AI projects which are unique in nature and that will help you to gain knowledge in the field of applied AI because you are implementing your AI into some project, and also will be unique enough in such a way that it will be helpful for you to get your maiden call up for interviews. So that is the aim of this playlist. This video, which is the first video of the playlist, is a banger. And I'm not gonna lie that, uh, set it up a banger and follow it up with some simple projects which will be like, man, I've seen it. Not in that way, right? So we are gonna build some projects which will be very unique. And first one of those in this video is about us building a lie detector using AI, where we'll be gauging our mind. That is why this project is known as Mind Gauge. Okay, and unfortunately, I'm blocking it. Let me show you. So the project name, like I said, is Mind Gauge AI, where we are gonna gauge the people's brain with the help of EEG machines, and then with that, we are gonna say, are they saying a lie or truth? Where did I get this inspiration? You see, I'm seeing this lie detection being a very good concept going around the internet. But if you see, always there is an expert who will detect whether it is a lie or a truth, right? But what if we can automate that with the help of AI? That is where my mind sparked, and I was going through n number of data set over internet, Kaggle, Hugging Face, and so on and so forth. And then I came across a research paper which said, like, because there were lots of data sets which had probably 2549 columns, 1500 columns. And though we can build those, it will be challenging. And I like to work with challenges. We might not have the computation, that is one. And then it is not very realistic for us to input 1500 at every time, right? So I was saying, like, is there a simpler way? Yeah, and then I came across a research paper known as EEG wave, sorry, lie waves based on EEG. That is somewhat the name I remember. And it said with just five, or did obviously five coordinates or else five values from five nodes or electrodes from the EEG machine, you can basically say whether a person is lying or saying the truth. I was like, yeah, man, that is good enough. With those five, I can do something else, right? It is very challenging because you don't know what is those five gonna say about, right? So I thought, okay, the data might be simple, but it is a complex use case. That is how you need to choose your projects, right? However, the data is, that doesn't matter. You should see it in such a way that that should have some real world potential. Imagine, I have a machine, I have those five inputs. I can just send it to my AI, which I'm creating, and then see whether I'm lying or saying truth, right? Simple. That is the aim of this project. I think this has been a long introduction. Now let's start with understanding the data because that is very important for us know what is going on basically. By the way, before going in deep, like I showed in the thumbnail, this will be an end-to-end project. I'll try to deploy it at least in local, like there will be a local inference for sure. But if it is possible, I'll also try to deploy it somewhere else because we might not have the resources for it. But I'll try, like let me put it in Streamlit Cloud or something like that. And the most important thing is I will be using ChatGPT. Yes, you're hearing me right. I'm being genuine here. I'm not gonna say like, I've coded it before, I'm gonna do it myself. No, that's not gonna happen. Everything is gonna be live. I'm just gonna use this one Chrome tab and you're gonna see everything how a corporate professional works. I'm a corporate professional. I'm working in AI. So you are gonna see how a corporate professional works. Yes, in interviews you can't use AI, but in real world that is how it works. And I'm a person who believes that you should be ready for real world rather than like some basic interviews. Obviously, you can do this if you do it 5 times or 6 times continuously, right? You will be ready to do it without even any AI. But that is not my aim. My aim is to prepare you for interviews as well as for jobs. Okay, so that is how it's gonna work. Now let me start with the dataset explanation. Obviously, there isn't any, but you'll see me explaining. So now here, if you see there are a lot of things, but what you need to know is live waves. You put it here, here you can see it is a paper, right? So they said, like, you can basically detect deception with the help of these five EEG signals, or that is what they are saying. Let me tell the abstract first, okay? Now you might think it is boring. Guys, I have provided every time frame. You think something is boring, you can just move on to the next section, okay? They have said that their study has introduced an EEG based dataset to analyze lie detection basically, and like there have been a lot of things which will be impacting it, but these five signals are more than enough, is what they have said. Here you can see EEG signals acquired from 27 individuals wearing a EEG device called emotive insight. So let me show you that as well. Emotive insight. Okay, so if I site or not, Amazon probably. Yeah, so something like this. So here you can see it is saying like five channels. So it is a real world thing. So if we can get that device, obviously it is 50,000. But in Indian rupees, for example, if you're a foreigner, that should be more affordable for you. But this is a real world project, right? So people used to ask me, like, what we can do for final year projects. This is something you can do, right? Because this is already a paper. You can try to implement it. They said they have got it from 27 individuals where they are taking five channels: AF3, T7, PZ, T8, and AF4. I know zero about these five. I'm being very honest here. I don't know anything about it, but they are saying those five are enough. I'll also take it is more than enough. But what we are gonna do is the first thing. Like I said, this is gonna involve a lot of ChatGPT. What are those five channel? Do you know about it? Explain in detail, but simple words of how these five channels are enough to detect whether a person is lying. Simple. So it is saying something. Okay, so apparently A means anterior part of the brain, F means frontal, T means temporal, parietal, and Z is midline. Okay, so AF3 and AF4 are the areas where you will think, plan, and make decision. T7 and T8 is about language, memory, and emotion, and PZ is attention and integration. So basically, you're thinking and you're refreshing your memory, and based on that, you are providing some attention and you are answering. That is what is provided here as an example, which does make some sense, obviously. And based on these is what they are saying, like, you are saying whether it is lie or not. That's great. Okay. In the first stage, they have created EEG data, and then in the second stage, what they have done is they have done some pre-processing where they have used some method known as ATAR. Okay, and I'm not going to go in detail to this. Even now, I'm not going to ask ChatGPT because I don't know. I don't want to know because that data is already here. See, ATAR. I don't need the raw data. I have ATR data, so I'll just use it. Simple, right? So why would we require to do something by ourselves? That's not required. Okay. Um. So now let's continue. So they have said blah 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 blah. They have used a lot of uh, things here. They have done feature extraction by using wavelet transform DWT. That is one thing which will be used in a lot of places. Okay, especially in audio section, you'll be using wavelet transform, fast Fourier transform. Those all will be required. And the last stage, each obtained feature vector was classified separately using CNN and LSTM hybrid algorithm. That's fine. But what we are gonna do, we're not gonna go in detail, right? See, they are saying it is 99.88% accuracy. That's fine. That's for another day. If you want, let me know. I'll try to understand this paper. Obviously, I need to somehow get this. That is one point. And once I get it, probably like, I'll understand what is the architecture they are trying to say, and then probably we can do it. Right now, we'll be using obviously CNN, RNN also will be there if time permits in this project, but I'll try to use it more with you know machine learning, because machine learning models are very lightweight and it is more like easy to use in real world in these kind of use cases. Okay, so what I'm going to do is first try to download these, obviously. So how am I supposed to do that? That is an interesting question. Yes. um okay, need to download the whole data set, man, not just this. Kaggle download a data set API. Okay, Kaggle datasets download, and then the dataset name. That's easy. So what I'm supposed to do, I need to get an API key. Uh, okay. What are they saying? Kaggle API, man. Where is the Kaggle API? There's something here. Settings. Oh, here it is. That's cool. Kaggle.json. This is another issue. Okay, let me use ChatGPT again. How to configure Kaggle API in Google Cloud. Got it. So I need to upload this. That is fine. Okay. Okay. Nice. So what I'm gonna do is here. I've already downloaded, right? So it is saying me to upload. So I'm gonna upload it. So right now it's asking for runtime. So it's connected here. That's fine. And I'm not gonna use GPU and all, guys. It is CPU. So which means like basic laptop with just an ability to run um this Google Colab in your system is more than enough, which is probably i3. Okay, below i3, I wouldn't suggest Pentium, those and all. Please don't. Okay. Um. So what are the things I need to do? I need to first do these. Apparently, well, here it is, configuring. And if you want, you can do along with me, or else, uh, wait for the video, understand what's going on, and then probably do it, because I'm gonna anyway provide you this specific notebook, okay, which will basically have everything. You need these two. Ah, um, yeah, I required this. Kaggle datasets. Okay, Kaggle datasets download. Apparently, I need to do this. Yes, download. I'm not wrong. It should be this one. Please work. Fingers crossed. Oh, that's nice. It worked. Cool. And okay, let me keep it this way itself. Here it is gonna be downloading data. So let me unzip it as well. So it's gonna be unzip live waves to zip. I think it is done. Live sessions and two sessions. 4 ATR CSVs. Okay. Now it's gonna be data preparation, not processing, preparation. Because I don't expect a lot of processing here. considering like there are just five columns, everything are numbers, probably I'll try to understand something, like how it is impacting, but I don't think we'll be getting any insight because we are not domain experts here, right? Obviously. So first I'll require from globe, import globe to get the paths, pandas, obviously for data frame related stuff. And if you are feeling some shake, right, it is because I'll just move it just to make sure it is recording the video. At the time you'll feel some shake, please ignore those. I request you on that. um Let me try to plot something, but I don't think we are understanding anything. So for that I'll have seaborn matplotlib as well. Matplotlib dot iplot as plt. Okay, I think probably will require numpy as np. Those are the required here. So first I'll have truth dir path be equal to truth sessions, and like I said, I'm gonna use the process to one. Okay, I'm not sure of what is going on in that. Okay, and guys, genuinely, this could be your final year project. Lie dir path, and why I am putting star csv, I think you guys might know. Right now you should have known because in globe it says in recursive whatever files are there doesn't matter, it should end with csv. That is what is the aim here. Even if it is a folder which ends with csv, which is not possible, uh, that will also be considered. Okay. um Now I'm going to take the live sessions, but live sessions ain't there. Oh yeah, it was slow, sorry, got confused. Guys, by these the genuine surprises, you should know that I'm doing it live. Okay, it's not like I've done this before. Even I don't know what accuracy we are gonna get. Anything above 85, I'll take it. Okay, to start with. Obviously, there you will understand different things, like which is important, precision or recall. Those are very important things to consider. I'll teach everything of those. Yes, this is a simple classification statement, but there are huge things for you to learn. Now, truth files. Root df, let me put it for that, is equal to what I can do is, yeah, root df is working. Root df is equal to pd dot concat pd dot read underscore csv of path for path in globe of truth dir path. Okay, so what it will do is it will go through each of those paths which will be matched here. We'll read it as CSV. That list of DFs will be combined as a single DF. Now I need to reset index because one after another everything will be zero. So for example, if it is 10 files, right? If indexed as zero, rather than giving one row, it will give 10 rows because there are 10 zeroth index here. Okay, and I'm dropping the index column as well. Guys, I'm trying very hard for you to make sure for even beginners you'll understand. All I'm expecting is just a few likes, a few comments, which will be probably encouraging for me. It can be even negative, uh, because again, that is another way of encouragement where you are saying this can be done like this, and I'm happy to take those comments as well. But please do comment something, and also subscribe to the channel if you haven't subscribed yet, because I'm trying to close in on 10K subscribers, and obviously I haven't been consistent, and there are huge reasons for this. Even now I have mouth ulcer. I'm talking with that. Um, so please, I request you all to hit the like button, share it with your friends with for these kind of projects, and yeah, uh, that is all I ask for. So we have truth and lie DF, but RDF is combination of these both, right? So DF is equal to pd.concat again, if you have guessed it right now, before even I said combination of these with the help of pd concat, you're doing good. Okay. Root df, lie df, both are concatenated. Spelling is wrong. So I need to first reset the index drop will be equal to true. Oh, yeah, I should have done something else. Truth df of label is equal to truth star len of truth df. Now, why I'm doing this? Because we don't know. Like, once you combine, right, you will not know whether it is true or false, right? That's why. Truth, lie, lie df, lie df. Correct, right? Truth df, lie df. Yeah, I think it's correct now. Reset index drop equal to sample frac equal to 1. What the sample frac equal to 1 will do is it will just shuffle the data frame. That's all. I don't want it to be like monotonic. Where did the error come? So um is there anything? Oh, are those pathways or what? Those are CSV, right? Ah, my mistake. Ah, bad times for me. So yeah, now we have a data frame which has 5 lakh columns. That's pretty huge. Okay. So now what I'm going to do is df.to underscore parquet. I'm a fan of parquet because it is fast. Okay. Um, it is like far better than CSV format. That's why probably I read it as parquet. My usual format is parquet. Okay. Lie detector data set dot parquet. I'm going to put it as raw because all of these are going to be provided to you. Okay, you might not even require to do these because like you need to do these and all calculation. You can just ignore those. Okay, I'll just provide you directly. I'll keep it downloaded in my local so that I don't miss it. um Now what I'm going to do is process the data if required. Right, I'll put it as EDA and feature engineering. Okay, EDA. And where is ampersand? Yeah, ampersand feature engineering. Shift is gone. I think gonna import some of those again. What are not required here? C1 is not required. These are all not required. Okay. Here globe is not required. I think everything others will be required. From sk learn dot model selection import train test split. Yeah. Uh I think now it's fine. Probably. First, let's do descriptive statistics. Okay. Can we find something? Is what I'm trying to do. Df.describe. Okay. So first I'll read the data set again. Df equal to pd dot read path width so that you guys can run from EDA and feature engineering itself. Copy path, put it here. Df dot describe. Now you can see, like there isn't a column here, right? That truth or lie, because this works only in numbers, right? We'll do that for that separately. So right now, um, seems like the mean and 75% is a closer. Is it true for everything? Where is the mean? 19, 14, everywhere, like the 75th percent is closer to mean. Doesn't mean like, lower values will have lesser. I think we should see some distribution. So first, let me get the categorical column out of the way. So, um, so here, encoder map. What can I do here? Let me not use this. Uh, uh, right now, I'll just have this inference. Mean seems to be closer to the seven third quartile. Okay, quartile possibility of outliers is something needs to be checked. Also, is there a skew in the data? Something needs to be checked, and if present, transform it. Okay, that is the aim for me, like when I did this describe. And then there is another thing, sns dot count plot if and x is gonna be equal to um was that label? I think it's label, right? uh, yeah, truth and lie are equal. Good times, we don't need to do imbalance, I think. um Inference data is balanced, imbalance handling is not required. That's good to know. Now let's see if there are missing values. F dot is null. I don't think there will be any missing values, so to speak. No, no missing values. Inference to no missing value. Okay, let me put it this way: missing values, target, balance, check, descriptive analysis. Yeah. Now I need to encode, handle categorical column, right? So unlike these people who use label encoder, right? I'm a personal fan of using my own encoding. Usually at times I'll see like how much the count is there, impact of columns, but here it is very balanced, so I don't require those. So what I'm going to do is label mapper. I'm going to create a label mapper myself, where I'm going to say uh, truth, lies bad, so I'm going to give him 0, and truth is good, so I'm going to give him 1. Simple, right? um so now df of label is equal to df of label. Now I'm calling apply function, which will go to each row of label column, where I'm using a lambda function, which is a single line function, where for each values this function will be called, which is label mapper of x. Okay, so I need to verify one thing here. Let me do that. Is it lie and truth? Yeah, because that should be same, right? Now let's check it. What happened? Not that. Yeah, now it's good. See, simple. Okay, now inference categorical column is handled, where lie is 0 and truth is 1. Okay, now I need to check for outliers. Um, Outlier handling for column in df dot columns. I'm not gonna separate dot to list. I'm not gonna separate a label from here because I can just do it here. Okay, this column not equal to label. SNS dot box plot of df comma x is equal to column. Okay. But I don't think it will show the plot. Yeah, I should do plot equal to. What is it? In PyPlot. Okay, let me first do it and then I'll ask ChatGPT. That's better. Um, oh yeah, I don't think it will show actually when it is in loop. Hey, it's showing. No, no, no. It is not right. No, it's not showing. Um, what is this? No, no, no. Make it show all the plot. This is what I was seeing for. See, told you right. See how many outliers are there. But my issue is, can I change a medical value? I don't think I can. That is my issue. No? What can I do here? You know what? Since these much outliers are there, what we can do is first let's train with this. But if it isn't enough for us, the accuracy, let's try to handle the outliers as well. Let me put it as my inference here. Since it is a medical record value, I ain't gonna change the value for now to handle the outliers, but huge outliers are present, and changing those would impact real world performance. First version without handling outlier. Second version will handle the outlier. Okay. Now uh, I need to see the distribution of those columns. Distribution of each signal. Already we have seen in box plot, we have seen there is outlier that's there. That's fine. But you know like how it is. So again, I'm gonna call the same this one. Okay. Put it here. Call it as this plot distribution plot. KD equal to true. I need a KDE curve. Okay. So it's distribution of column. Into float. What do you mean? Do you need only value? Ah, okay. EF of column. Ah, shall I cry or what? Like, see, this is a good curve. so to speak. But like there is only till one standard deviation from -1 to +1. Where are the others, man? God. You see, like, is it a synthetic data? I'm not sure, but I assume it is not because it is a research data set. See, they have made research papers out of it, so I'm assuming it's not a synthetic data set. But how can a data have this much outlier and be in this distribution, man? Ah, okay. I don't think I require any transformation, though there are many outliers. Still, the distribution is kind of Gaussian, normal, so no feature transformation is required. Yeah. Oh, yeah. Now outlier handling is done. I don't think we need to do any feature transformation. Feature selection is not required because already we have only five. Um, yeah, I'll put it as a separate here. Train test it. Um, X is equal to df of df dot drop off label. X is equal to 1. Y is equal to df of label. X underscore train, X underscore test, Y underscore train, Y underscore test is equal to um what is it? Train test split off. Oh yeah, comma Y, X comma Y, and I'm gonna say test size is equal to, and I'll take 20%, which is 0.2. Um, Shuffle. I'll probably shuffle. Oh, sorry. I'll probably shuffle my random state is equal to 42. There is something else. I'm forgetting it. I'm not sure what it is. That's fine. Uh, len of extreme of x test. Oh, I forgot one thing. I should have done feature scaling. Yep. Did I do that? But if I do that, like it will handle that outliers to some extent. Let's try that. I forgot it. Yeah. Thank God I remembered it. Feature scaling. How did I miss this, man? Uh, from sklearn dot, what is it? Scalar or processing? I think it is sklearn dot processing. Import min, no, standard scalar. Sklearn standard scalar. Where is it from? Oh, it's pre-processing. Guys, it has been so long I've done machine learning. Okay, that's why this thing is happening to me. Sorry about that. Standard scalar. If you're wondering, it works based on the x minus mu by sigma formula. That is how it works. But what am I supposed to do here? Is it okay? Yeah, I'll do it here. Okay, x y int split. So I need to push that here. Here is where I need to add the feature scaling. because for y I don't require, right? That's why. Okay. Um, for x is equal to standard scalar of uh of x. X is equal to scalar. Sorry, it should be fit in transform. So okay, let me do one thing. I need to save my scalar as well. Um, how to save the standard scalar with joblib? I think it should be joblib.dump because it also requires like using pickle behind the scene. Yeah, that's fine. Okay. Yeah, pickle extension. I'm right. I'm just verifying. I'm just being verified. That's all. Scalar dot fit. Let's go transform because this will be fitted on our data. Find r median. Find r median because the formula is given a value. It is x minus mean of the data by standard deviation. Okay. So you need to have your scalar ready. So x is equal to scalar dot fit transform of okay. Um, and I'll verify it is fit and then save it, right? Or fit transform can be called. That's fine. Okay. Now we have that. Uh, where is it? Import joblib. Joblib dot dump of scalar as scalar dot pickle. Okay. That's what I'm requiring it here. Again, I'm just this shake came because I'm just verifying if my face is on the frame. Okay. Sorry about that again. Um, I need to call this scalar.pickle should be ready here. I'll download that as well. Okay, scalar.pickle is downloaded. Now I should call the train and test. Before I need to check one thing as well. Check outlier. Box plot. X of 0. It is an array of array format. Ah, we need to see the box plot of scale data. Try format. It will just convert that again here. Just give me a minute. You. So now what I'm gonna do is um call this I don't think this will work, actually. Oh, it is doing parallel. But still. The outliers I didn't handle as I expected, but I thought the range will come behind, actually. Okay. X. I'll put it as X scaled. I need the difference, actually. Okay, it is something else. Here it is. The range is lesser. Not sure. Oh, yeah, that's fine. I think it will be handled a bit, actually. At least that's what I thought. I think the plot was wrong there, actually. Now my brain test split is done. Do I require 1 lakh, 4 lakh, 14,000, 1 lakh? Probably no, actually. Put it as 10%. 15,000 is more than enough. Yeah. Now my data is ready. Time for model training. Okay. Um, from sklearn dot linear model code logistic regression from sklearn dot what is it, SVM, import support vector classifier from sklearn dot key code decision tree classifier, random forest classifier. Forest media. Oh, it's ensemble. Sklearn dot ensemble code random forest classifier. Add a boost. I think these two will be there. From XD boost code XDB classifier from cat boost. That boost is not there. Okay, let me install that. Okay, cat boost is being installed. From cat boost import cat boost classifier. What? Cat boost classifier. What was the input here then? I thought it was cat boost classifier being input like this. Quick start. Yeah, see, this is like this. I don't know why. Okay, probably it didn't compete correctly. Did I leave something? Yeah, neighbors. That sklearn dot naive port Gaussian NV. Gaussian curve it was there, so I'll take Gaussian naive bias. All of these are done. So what I'm gonna do is I'm not gonna write. Uh, I need to evaluate as well. That also I'll give it to them itself. From sklearn dot fix metrics code classification code precision score code. Take that as well. Oh no no no. I'll take ROC core ROC curve Accuracy score, precision score, fault score, F1 score. Take all of those. Now what I'm gonna do is wait for the magic to happen. I have data set as X train, X test, Y train, Y test, right? By the way, did I give the format correctly? Like that actually. X test. Okay, that's correct. Um, yeah, where Y train has two labels, 0 and 1. Now I need you to write a training trainer loop for all the models and have a reporter will generate all of the reports for the scores I have provided, and if there are graphs will be saved based on the model name. Even the score can be saved as JSON with the model name. Let me give it. Let it do, because if I do, it will take some time. But if he does that, simple. Let me try this, but I'm not sure. Let me add TQDM as well and the progress bar. And TQDM for progress bar. Let it be there. Whatever. Put it here. Oh, oh yeah. That's what I'm talking about. Training logistic regression. Training models logistic regression is done. Wow. SVC will usually take time actually. Okay. So here accuracy has been 50, 55, 52. Classification report is good enough, but ROCEC is also 51. 51 is not something which is sufficient. So logistic regression is no, 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 no. We are not going to consider that. Okay. And for plots, logistic regression ROCEC curve. This is not good, man. Oh no, no. This is not good. Oh yeah. That's what I'm talking about. Let's just wait. Um, maybe I'll give a time lapse here. Let me come after the training is done. I've been waiting for so long, but this SVC hasn't been training. So what I'm gonna do is I'm not gonna have SVC actually my training. Restarting. Ah, again I need to do it, man. Really, I avoid, like SVC, which it will take time, usually a long time to train. Ah, now itself I'll take SVC out. Um, I don't think logistic regression or Gaussian areas will do any difference. I'll take out those out of the scene as well. And yeah, that's what I'm talking about. Are all of those done? Yep. Done. Download the scalar pickle anyway once again. Then now I'll run this. Now it's training decision tree. Hopefully at least this will be faster because the RAM is not used that much, but it is being very slow, to be very honest. What am I supposed to do if it takes this long to train? There are 5 lakh data points. That is something probably which would take time, being honest. Should have probably reduced it. Okay, let me leave it then. No, let me leave it. I'll see you all after the training. So yeah, guys, training has been done, and as expected, none of those were good enough. So what I'm gonna do is right now, just hyperparameter tune. Simple. Okay, just hyperparameter tuning because out of all of these, okay, out of all of these, Cat Boost, which I expected to perform really well, was the best model. Okay, so what I'm gonna do is just take that model and then fine tune it from there. Okay, so that is the aim here. I have asked the code to ChatGPT. It has given with GridSearch CV. Let's do with GridSearch CV itself. That's not an issue. And if it doesn't do like enough tuning, right, then probably I can do it with the help of things like Optuna, HyperOpt, things like that. Okay, I'll take iterations 300, 400, and then 500. Yeah, learning rate. I'll ask him itself. Give me more better grams. What is he doing? Oh, he's doing. Why is he even this low? I'm not sure. Okay. First, let's try this, and then let's try that. Okay. Gram grid. Okay. Yeah. Let me do this. But I'm not sure, like, how long this is gonna take. Let me again wait for that. Okay. Uh, that one is very high, guys. Like, that big one was very high, so I had to, like, go for a lower one. So I've gone for a lower one. Let me see if this works. I'm hoping to get at least 60. I was in 85. And by the way, there will be a part two for this. I'm not going to leave it this way. We are going to use deep learning for sure. But like I'm running short of time today. That will be our part two. This part one will be still end to end. I'll deploy this pickle model in a Streamlit cloud or somewhere else, and then we can run it from there. You we can do that actually. That is better. Um, So yeah, that is the aim here. But right now here you can see it is training actually. So it's been training for so long. I'm assuming it is gonna actually hang the the collab probably will hang actually. I'm not sure, but yeah, let me see. Uh, you know what we can do until this gets ready? Is there any model I have here? Fortunately, I don't. That's good to hear. If there was a model, right, I was planning to, like I could have just saved it and then probably write an inference code. That was the plan for me. But yeah, unfortunately, it doesn't seem that I have a model. Save my mistake. Sorry. So yeah, let me wait for it. So guys, actually, there is a small issue in this. Um, so what is the issue is it took around 2 minutes, I guess, last time. Okay, so this was the less, you know, that GVD gave, say, right? Like for a compact optimized grid, try this. That's what they said. So here it was 2 minutes approximately, and here it is 192 fits. Okay, unfit it took 2 minutes. 192 it should take 5 hours. So let me assume a best case of 3 hours. I don't want to try for that much time because this is not something I want to like put it on. But still, I'm gonna put this code here because I want you guys to try it. Then tell me what was the best performance. Okay, right now I'm just gonna say like, ah, whatever is there, I'm fine with that. That is what I'm going with, and let me see how long this takes. What is the performance I'm getting out of it? Okay, in the same time, what I'm gonna do is I've added a code called model.pickle save. I'm commenting this out because once this training is done, I will not save it. You guys can save it. Okay, once you do this hyperparameter tuning, right here itself there is a save function, you can save it. Now what I need to do is I need to write an inference code. Okay, so what are all the things I have done here? I need to take 5 inputs and then I need to scale it with the help of the scaler, right? This way will work. Is the training done or not? Yeah, the training is done. Awesome. Oh, okay, import full. No, that as joblib. I'll restart my session so that you guys know that I'm doing it genuinely. Joblib inference. So here the model is going to be joblib dot load of model dot pickle, and my scaler is going to be joblib dot load of scaler dot pickle. Oh, I need to download this as well. I forgot it. Yeah. So now I'll print and see my model. I'll print and see my scaler and a scale. Yeah, good. So now data is equal to just add commas. Model dot predict of scalar dot transform of data. What? Should I give it as an array or what? Something like this probably? Yeah, okay. So what I'm gonna say is data is equal to x, let's go test of 0. Oh, that is not there. That's cool. Uh, Let me go here. Something where I know there is a value. Okay, here it is. We take the first one, and the label was 1. We made a wrong prediction, and that is expected with this kind of an accuracy. But yeah, the inference code is there, right? So what I'm going to do is uh, write a Streamlit app for inference based on the following. Okay, guys, I know you might have had a lot of expectation, but this is how. Oh, take. We need to experiment a lot. You know? That much paper was the given. Like, we can try to use CNN and stuff like that. Okay, we can try that. Oh, sorry. See, I just got bored and I started playing chess actually. That much time it took. Couldn't afford that much time actually. Here the data column are. Now if I write the Streamlit app, right? Uh, that should be good. Okay, copy. So what I'm gonna do is I'm gonna go to my VS Code and then I'm gonna paste it. You guys wait for it. So yeah, guys. I already did it in my local. All I did was just download those data, notebook, model, scalar. Everything is now ready. This will be uploaded in GitHub, obviously. So now here you can see there's a code. Obviously, you all saw that I took this from ChatGPT. Probably next time we'll try Cloud as well. That will be good. Uh, so here, I don't think this is required. Here you will require some requirements.txt, which is just basic. Okay. Now, if you go and run Streamlit run app.py, it is asking my ID, which you all know because that is in the description. So I don't have any problem in showing that. Yeah, I was just searching for this tab actually. All right. So here's my tab, and here are some values. Okay. So these are default values. You can just add those or reduce it. Oh, you can do anything you want. Add it, reduce it. Okay. Anything can be done. If you call predict, the predicted class is 0. Okay. The app is now ready. Okay. So now what I'm going to do is I'm going to show you how you can deploy this. So first, you need to upload these to GitHub and then deploy it in Streamlit Cloud. So what I'm going to do is let's have this, for the next session. I want you all to attend the next session. So what I'm going to do is I'm going to do the ops side, which is deployment, on the next session, where we'll also do the you know improvement of the model part. Probably I'll run that cat boost as well today. It will run till evening. That is also there. So that is the aim of this video. Like I said, I promised I'll do it in local is done. We'll do it in like GitHub as well. I'll again promise for that. We will do that. Okay, I promise again for that. So yeah, guys, I hope you like this video. If you like this video, please hit the like button, share it with your friends. If you haven't subscribed to the channel, please hit the subscribe button, because um like, I'm being genuine. I'm doing everything in live. Nothing is not shown. Okay, everything is shown here. I'm being genuine, unlike a lot of other channels. I don't want to name guys because they write on others code. Like, they'll ask people to code and they just show, and they're just big guys. No, I'm not doing that. I'm showing everything to you. So please, for the genuinity, I would like to take your support. But if you think I'm doing something not well, let me know that as well in the comments. I'll try to improve myself. I hope you all have a great day ahead. I'll see you all in the next part of the same video. Until then, happy learning.